Before we could, well, welcome to screencast number 5, first of all. We're going to look at managing the risks in the nuclear power plants. Primarily, we're going to focus on that for the main part, and we're going to also think about the waste disposal, the challenge that that is going to face. So, nuclear power, even though it is efficient, as we've heard, there's some definite risks in using it. And we have been very fortunate that we have not experienced more accidents on the scale of those that we've seen with Chernobyl and Fukushima. We have had smaller scale accidents that haven't gotten the news as much. In 1999, and I think I need to take Japanese to pronounce half of these because many happen over in Japan. There was a plant called the Tokiyomura that killed 2 workers. It exposed over 400 others to leaking radiation. So that was a little bit of a minor one. Sweden experienced a near miss in 2006 when the Forsmark plant north of Stockholm narrowly avoided a meltdown after 2 of 4 generators started up following a power outage. In 2000 and 2012, U.S. reactors had 9 emergency shutdowns in responses to tornadoes and hurricanes, earthquakes, and flooding. So there have been other incidences. The good news is the design of most of the modern reactors are safer now than they were for Chernobyl. The designs for future power plants promise more safety features as well. Most emergencies at the reactors around the world have safety systems that have functioned really well. We can go back to Japan and the Onagawa power plant, which was very close to the epicenter of the earthquake in 2011. All of its safety systems were protected, and it kept it from any serious damage. But we also have to consider as well, plants around the world are aging. They're getting older, and when you get older, you require a little bit more maintenance and you become less safe. So please, as I had said in the last screencast, make sure that you're reading the science behind the story on page 562 and 563, which continues the story of Chernobyl and Fukushima. There has been concern that radioactive material could be stolen from plants as well and used in terrorist attacks. That has been a huge concern. There's the possibility that it has been especially worrisome in the cash-strapped nations of the former Soviet Union. There are hundreds of former nuclear sites that have gone without any adequate security for many years. And there's that ever-present concern that more nations may develop nuclear weapons, and we see this happening with Korea right now. The United States and Russia have embarked on a very remarkable and successful program called Megatons to Megawatts. And this is a cooperative international agreement where the United States has been buying up weapon-grade uranium and plutonium from Russia. And it's letting Russia process it into lower enriched fuels. And they're diverting it to the peaceful use of power generation. About 10% of America's electricity has been generated from the fuel recycled from the Russian warheads that used to be at top missile points at American cities. In 2013, it was expected that the last of the 500 metric tons of highly enriched uranium will be processed and transferred. And after that, the United States is planning to negotiate some sort of continuation of the program. So now we have to take a look at waste disposal, because that is what remains the biggest challenge. While making the energy doesn't put any pollutants out, and it's relatively clean, the equipment, those rods that have the neutrons trapped in them and the radiation trapped in them, and the waste that's produced because of it breaking down into smaller types of radioactive isotopes, that needs to be disposed of. And how do we do that? What do we do with those spent fuel rods and the other radioactive wastes? Fission, if you remember, since we talked about this, it utilizes uranium-235 as the fuel, and it leaves about 97% waste of uranium in the form of uranium-238. This uranium-238, as well as the irradiated material and equipment that is no longer being used, has to be disposed of in some location that prevents radiation from escaping. And we have to remember that the half-lives of uranium and plutonium and many other radioactive isotopes, they are far longer than multiple human lifetimes. You know, we were talking about it being 700 million years, so a long time. So the waste will continue emitting radiation for thousands of years. The radioactive waste must be placed in an unusually stable and secure location where the radioactivity will not harm future generations. So currently, the nuclear waste from the power generation is being held in temporary storage at nuclear power plants across the world. Spent fuel rods are sunken in pools of cooling water to minimize radiation leakage. Most of the U.S. plants have no room left for this type of storage, so they are now storing waste in thick casks of steel, lead, and concrete. The U.S. power plants are storing nearly 70,000 metric tons of high-level radioactive waste, enough that would fill a football field of the depth of 21 feet, as well as much more low-level radioactive waste. And this is being held at more than 120 sites spread across 39 states. And some of us live very close to where they're being stored. There was a 205 report from the National Academy of Sciences that judged that most of these sites were vulnerable to terrorist attacks. There are 161 million U.S. citizens that live within 75 miles of the nuclear waste. So we're probably one of those places, since we have 3 Mile Island and we have Limerick nearby. Storing the waste at dispersed sites does create large problems. Here's the ones that are stored underwater, and there are the ones that are stored in the big containers in dry storage, as you can see. Here are the states, the 120 sites in the 39 states across the United States. The dots indicate storage sites, and the colors indicate the amount of waste stored in each site. So let's take a look at Pennsylvania. Oops. Taking a look at Pennsylvania and New Jersey. We've got 3 right within our area. And look at it. It's the darkest blue, and it's metric tons. So we have a little bit less than 1,000 metric tons of spent fuel that is within our area. And that can be pretty scary because, as it says, they're concerned that they're vulnerable to terrorist attacks. So that's something we have to think about. So storing the waste and dispersing it at these different sites creates a large number of potential hazards. So nuclear waste managers have gotten together and they discussed that it would be better to send the waste to a central repository, and that central repository then could be heavily guarded. So Sweden tried this out. It conducted a 20-year study, and they were looking for a suitable location, and in 2009 they selected Forsmark, the power plant site, as its single disposal location. The site was approved by the government, and the agencies constructed everything as planned. They spent fuel rods and other high-level wastes that will be systematically buried in canisters that will be buried about 1,650 feet underground within a stable bedrock. So that's how they're going to take care of their nuclear waste. In the United States, we too did a multi-layer research and discovered that the Yucca Mountain was a remote site in the desert of southern Nevada. This was 100 miles from Las Vegas, and they thought that after studying the site and spending about $13 billion to develop it, that this would be the best place. But Nevadans didn't like that choice. They weren't happy. And in 2010, as the site was awaiting approval for the Nuclear Regulatory Commission, the Obama administration ended support for the project. Ironically, this just came a few days after Obama had urged expending nuclear power in his State of the Union address. Political observers had agreed that the Senate Majority Leader at the time, Harry Reid, who also represented Nevada, was one of the key reasons he changed this policy. But in 2013, the issue remains unsolved. There have been a number of lawsuits that are in progress challenging the decision. And without this Yucca Mountain repository, the United States has no place designated to dispose of any of the radioactive wastes. If they had used the Yucca Mountain, they would have been able to store this waste material in a network of tunnels that were 1,000 feet underground, and yet still be above, like 1,000 feet above the water table, so that they wouldn't affect the water table. Scientists and policymakers who chose the Yucca Mountain site because they determined that it was remote, unpopulated, and had minimal risk of earthquakes. It receives little rain that could have contaminated the groundwater with radioactivity. It had a deep water table atop an isolated aquifer, and it was on federal land that could have been protected from sabotage. But there were scientists and anti-nuclear activists and even Nevadians who challenged the conclusions that they came up with. So taking a look at this picture, we see that this is the Yucca Mountain. Okay, so it looks like there's very little going on in the mountain, life-wise. This is the scientific testing that they had done of the area, and then here is the plan. And the containers would be stored in these tunnels that they created. The water table, you can see, is really far below at this point. So it looked like it was the best place for the storage. So, as I said, scientists and activists had challenged this. Now, one of the other concerns that they had was this nuclear waste that we had in these 120 some locations. They would have had to have been transported to this dump site, and they were concerned that the shipments, whether they were by rail or truck or public highways, people would worry that there would be risk of accident or sabotage. That would be huge and unacceptably high. So this is another reason why it was held off.